Question number 3 in the EOT part 2. So now we have this type of functions and we need to find the limit. So whenever we have such type of functions, we have to think about either number 1, factoring, number 2, simplifying, number 3, rationalizing, number 4, using trigonometric identities or special limits. Now to start with question 25, I always start with direct substitution. Limit as h goes to 0. So if I substitute 0 in the place of h, it will be 2 plus 0 squared minus 4 over 0. 2 plus 0 is just 2. 2 squared is 4. 4 minus 4 is 0 over 0. Now whenever you get 0 over 0, this is called indeterminate form. What does indeterminate form mean? It does not mean there's no solution. It means that we can find maybe the solution in another method. So let's start here. I can see that here there's a bracket that is squared. So the first thing that I would try to do is open this bracket. If you remember, whenever we have something in the form of a plus b squared, we open this by saying a squared plus 2ab plus b squared. Or if you didn't remember the rule, 2 plus h squared means 2 plus h times 2 plus h. So it's multiplied by itself 2 times. And then you can expand this using FOIL method. Okay, so when I expand this one, it's going to give me limit as h goes to 0, 4 plus 4h plus h squared minus 4 over h. Now 4 and minus 4 will cancel and we will end up with 4h plus h squared over h. Now if you try to attempt direct substitution again, you will end up with 0 over 0. So this means we are not done simplifying. Now here I see I have h squared. So I can take h as a common. We will be left with 4 plus h over h, limit as h goes to 0. Now I notice h up and h down will cancel. So I am left with 4 plus h as h goes to 0. Now your next step after cancelling a variable is trying to substitute again. So now I see here 4 plus 0, that is equal to 4, and that's it. We got the answer to be equal to 4. Now this question can be found using the calculator as well. In the calculator, whenever you do by calculator, you need to find the limit from the right and you need to find the limit from the left. Now how am I going to find the limit from the right? All you need to do is substitute in the calculator a number that is higher than this. Okay, higher by how much? Just by 0.001. So to find the limit from the right, just add 0.001 to the number you have here. To find the limit from the left, just subtract 0.001. So for example, here I have 0. So if I add 0 to 0.001, I will get what? 0.001. If I subtract 0.001 from 0, I will get minus 0.001. So now I will go to my calculator and I am going to do the following. I am going to write the function same as it is. So I will say 2 plus, since we don't have h in the calculator, we will use x minus 4 over x. Then I am going to click this calculate button and I am going to say I want to calculate this at 0.001. I click equal, I get 4.001, which is approximately 4. Now if you want a more accurate answer, what you can do is add more zeros before the 1. So I can say 0.00001 and then again I click equal. I see the answer is getting closer and closer to 4. Again, if I want it more accurate, I will add much more zeros and I click equal. So now the answer is exactly 4. So from the right we got 4. Now I will go again and I will do this from the left. So now I will put minus 0.00001. And then what do I also get? 4. So from the calculator, directly the answer is 4. Since this is a multiple choice question, you can go ahead and just find the limit using the calculator. Now, to find the limit of this, I am going to expand 1 plus h cubed. Now again, how do I expand this power 3? This is very simply 1 plus h multiplied by 1 plus h multiplied by 1 plus h. You can multiply these together. So you will get 1 plus 2h plus h squared. And then this answer, you will multiply it with 1 plus h. Now when you do this, you are going to get an answer. This answer is going to be, if I use my Pascal triangle, if you remember this from grade 10, if you don't, it's fine, just do this, whatever is here. So we will end up with 1. First I will write the limit as h approaches 0. 1 plus 3h plus 3h squared plus 1h cubed minus 1 over h. Now again, notice 1 minus 1, they will cancel. I will end up with 3h plus 3h squared plus h cubed over h. Now if you try to do direct substitution here with 0, all of this will be 0 over 0, which is indeterminate form. So I look here, I see that h is repeated. So I can take h as a common factor from these. What will remain is 3 plus h squared over h. H and h will cancel. Now your next step directly after cancellation is to substitute what? The 0. So now I will end up with this cancelling, because anything times 0 will cancel, and we will be left with 3. So the final answer is 3. Now again, how could I have done this with the calculator? I will go to my calculator. I will write the function same as it is, 1 plus x cubed minus 1 over x. Now I will click calculate. Now I want from the right of 0. So same like we did in question 25. I am going to put 0.00001 and I will click equal. See, directly I got the answer to be 3. Now I will check from the left side. So I will put minus 0.00001 and I got 2.99999, which is almost 3. If I want a more accurate answer, just add more zeros. So now look, the answer is 3. So that's it. This is the answer. Okay, now I continue. I see that we have the limit of sine x squared minus 4 over x squared minus 4. Now over here there is a famous limit that you need to be aware of. And actually in the question, they did remind us of it. If you go back to the first here, they said assume that the limit of sine x over x as x approaches 0 is 1. So we are going to use this one over here. So I'm going to say limit of sine x over x as x approaches 0 to be 1. Okay, now you might be wondering, this does not look like this. So how am I going to use it? Well, technically the rule says that if you have sine an angle, which is x, over the same angle, okay, and x is approaching a number that will make this angle 0, then the answer is 1. So look, if you were to put 2 here, 2 square is 4, 4 minus 4 is 0. Again, 2 square is 4, 4 minus 4 is 0. So notice that this number will make this 0, will make this 0. So this means directly that the answer of this is equal to 1. Now, how could I have done with this with the calculator? Same thing. In the calculator, all you need to do is find it from the right, find it from the left. Again, from the right, you are going to add 0.001. From the left, subtract 0.001. Add and subtract to what? Again, the number you are approaching. Here we are approaching 2. So I will say 2 plus 0.001. That will be 2.001. From the left, I will subtract 2 minus 0.001. That will give me what? If you go to your calculator, you will see that 2 minus 0.001 will give me 1.999. So I'll say 1.999. Now I will go and I will do the same thing we did in the previous questions. I will write the function same as it is. So here, of course, make sure your calculator is on radians over here. So here you should see the letter R. So I will write sine x squared minus 4 over x squared minus 4. I will click calculate and I will write 2.001. Click equal. Now notice the answer 0.999999, which is almost 1. Again, if I add more zeros before the 1 and I click equal, so now look, the answer is 1. Okay, now I will do this from the left. From the left, I will put 1.999. Click equal. Also, it's almost 1. Now, how can I make this even more accurate? Add more 9s. If you want the exact answer, add more 9s. So now look, the answer is exactly 1, which is the same as we concluded. Okay, question number 28. Again, you can go ahead and do this with the calculator. So here, I will write the answer, I will write the function tan x over 5x, and I will click calculate. Now I want from the right, we are approaching 0, so I will do 0.001. I got 0.2. So from the right, I got 0.2. Now I do this again from the left. I click calculate minus 0.0001. Again, what did I get? Also 0.2. So this means that the answer is 0.2. Okay, how can I show this by solving this question? Very simply, we know from our trigonometry that tan is the same as sine over cosine. So what I can do is replace tan with sine over cosine. So I will put sine x over cosine x, all of it over 5x. Now how can I rearrange this fraction? Look, 5x is like over 1. There is nothing underneath 5x. Now you multiply the very upper one with the very lower one, and here the lower with the upper. So sine times 1 will give me sine over cosine times 5x will give me 5x cosine x. Now notice I see there is a sine up and an x down. Now what do we know about the limit of sine x over x as x approaches 0? It is 1 from the special limit. So I can replace this with 1 over 5 cosine x limit as x approaches 0. Now let's substitute in the place of x 0. So I will get 1 over 5 cosine 0. We know cosine 0 is just 1. So cosine 0 is just 1. 1 times 5 is 5. So the final answer is 1 over 5. If you convert 1 over 5 into decimal, you will see that it is 0.2, same like I got from my calculator.